Right, grade 11s, the final question from the trig consolidation, okay? Right, so question 5. The first question says to me, if the sine of 40 degrees is equal to P. Now, as soon as I see something like that, I say to myself, hang on, sine is a trig ratio. A ratio means it's a fraction. So it can't just be equal to P. It's got to be P over something. And the only thing that I can put P over to make it into a fraction is over 1. Okay, now I have two sides in a right angle triangle. Because it's sine, I know the opposite and I know the hypotenuse. So I draw myself a little right angle triangle in the right quad. Okay. Put in my 40 degrees and I say sine is equal to opposite over hypotenuse. Okay. I can now get, and I'm going to call this side x. I can now get x by using Pythagoras because it's a right angle triangle. So I can say 1 squared is equal to p squared plus x squared. And remember, as soon as you use it, you have to acknowledge him in full. And I get 1 squared, which is 1 minus p squared, is equal to x squared. And therefore, the square root of 1 minus p squared is equal to x. You leave it like that. It is never, ever, ever going to get rid of its square root sign. So x is equal to 1 minus p squared. So I've done that before I've answered any questions. Okay. All right. So now I'm going to go to my question. So question 5.1.1 says to me, find the sine of 220. As soon as I see that it is an angle that is greater than 90, I know I'm going to have to use reduction formula. All right, if I need to, all stations to Cape Town. Okay, the course diagram, 220 I know is in the third quad, so I know that sine is negative. All right, and I want to know what must I add to 180 to get to 220. When in my head I just go 220 minus 180, which gives me the negative sine of 40. But I know what sine of 40 is equal to, it's p. So surely my answer here is just going to be negative p. Question 5.1.2. They want the cos of 310 degrees. Again, the first thing I notice is I'm going to have to use reduction formula. 310 is in the fourth quad. What do I know about the fourth quad? And cos, it is positive. 360 minus what will give me 310 is the same as saying 360 minus 310, which gives me the cos of 50. Okay. Now I've got to relate the cos of 50 to the sine of 40. So I say, but hang on, 50 plus 40 gives me 90. Therefore, these are going to be co-ratios of each other, and the cos of 50 will be equal to the sine of 40, because those add up to 90, i.e. it will be equal to P. 5.1.3. They asked me to find the cos of 40 degrees. Now remember, I drew a triangle earlier, and I've got all three sides that go with 40 degrees. So cos talks about adjacent over hypotenuse, so I look in my triangle, and my adjacent is 1 minus p squared, and my hypotenuse is 1. Or you can obviously just leave that as 1 minus p squared. Okay. Right, question 5.2, the last one. It says to me, find the general solution of the sine of 2 theta minus 40 degrees is equal to negative 0,5. It is a trig equation and they want the general solution. My method is QRA. What quadrants am I going to be in? What quads? Now, how do I find that out? By the sine. In this case, sine is negative, So I know it has to be in the third and the fourth quads. Reference angle. Okay, to get my reference angle, I ignore the sign. So the sign is negative. So all I'm going to do is shift sign of 0,5. And if I do that, I get my reference angle is 30 degrees. And then my arguments. If I was in the first quad, I would have theta plus 360k, where k is an element of integers. If I was in the second quad, I would have 180 degrees minus theta plus 360k, where k is an element of integers. If I'm in the third quad, I have 180 degrees plus theta plus 360k, where k is an element of integers. And if I'm in the fourth quad, I say 360 degrees minus theta plus 360k, where k is an element of integers. Remember that those will work for sine and cos. As soon as it's tan, then remember this, okay, if it was tan, would change to 180k, because the tan graph repeats itself every 180 degrees. All right, so let's go back to our sum. Okay, so the first thing we know is that we know that it's going to be in quadrant 3 and quadrant 4. Quadrant 3 and quadrant 4. Second thing we know is that if we go sine to the -1 of 0,5, we get our reference angle of 30 degrees. Now I'm going to build my arguments. So I know I'm in the third quad. So in quadrant 3, 2 theta minus 40 degrees must be equal to 180 degrees plus 30 degrees plus 360k, where k is an element of integers. Therefore, 2 theta is equal to, use your calculator, 180 plus 30 is going to give you 210. 210 plus 40 is going to give you 250 degrees plus 360k, where k is an element of integers. And my final thing is I've got to get rid of my 2, so I divide every term through by 2, and I get 125 degrees plus 180k, where k is an element of integers. And that is my general solution for quadrant 3. Quadrant 4, I'm going to have 2 theta minus 40 degrees is equal to 360 degrees minus my reference angle plus 360k, where k is an element of integers. Again, use your calculator. 360 minus 30 is 330. 330 plus 40 is going to give you 370 degrees plus 360k, where k is an element of integers. And my final step is I divide through, and I get 185 degrees plus, remember that your period also changes, 180k, where k is an element of integers. Right, and that is the end of the consolidation test.